Well, good morning and welcome to Nani Notes. Today's topic is similarity. Similarity that you're going to find if you're using that textbook in Chapter 6. And then we're going to introduce Angle Angle in 6.4. So that's our textbook, McDougal, Littel. But yeah, it's geometry is geometry. Let's just follow along. I'm going to start here with two polygons. And so just sit back and let's review the concepts. I've got these polygons that are, well, I guess they're pentagons, and they've got the same shape. Now, the same shape really means something specific. It means that they've got all the corresponding angles are congruent, and all the corresponding sides are proportional. So let's suppose I made it look so roughly, yeah, each of the red sides is roughly twice as big as the corresponding blue side. Those figures are similar. And that's really what you've learned. That's it. It's pretty simple when we're talking about polygons. Well, the fact is, it doesn't even have to be polygons. It could be these shapes, right? And these shapes are also similar. They're not polygons. Makes me think about having my toast in the morning. But there you go. Got curves in them. Or it could even be something more complicated. Heck, when I took this picture, I had Nani's footprint right next to a wolf. I said, hey, they're similar. Why? Because they are. Similar species, similar footprints. So let's go a little bit of a review right now. Oh, I think I'm going to lose this screen so you can see. Okay, so that's what we said. Polygons are similar. IFF means if and only if. Well, all the pairs, corresponding angles are congruent. Corresponding sides are proportional. So the angle A, well, just like with congruence, we got to list them in order. A is the first letter, E is the first letter there. So the A matches the E, the B matches the F, your BF, and C matches the G. So the angle C is congruent to the angle G, and you can see by the congruence tick marks as well. And D is congruent to H. It also means that all the sides must be proportional. So if I were to measure them, BC is to FG, as CD is to GH, as DA is to HE, as AB is to EF. All right, well, that's just conceptual. That shows you what's going on a little bit. Let's try this example. What do you think of this? I've got I made these two shapes. They're pentagons. You can tell I love odd numbers. All these angles, 110, 50. What do you know? You've got 2 or 5 pairs of congruent angles. Similar? What do you think? No. They are not. Say, well, how was that? Well, just look at that. I changed it. I stretched it out like that. And you can see it's just pretty obvious that these guys are not similar. So, congruent angles. It's going to work for triangles, but congruent angles alone does not make a pair of similar figures. Now, the example is probably more clearly illustrated here with aspect ratios. Say, what's that? Well, back in the days, you got a DVD and you said widescreen, full screen, widescreen. You went into Blockbuster and you got a DVD and it depends what kind of TV you had. Old school TV was like this. We call that an aspect ratio, the length to the width with a ratio of 4 to 3, or widescreen, just like your cell phone, 16 to 9. And these two, well, they're both rectangles, which means they're equiangular, but they are not similar. What do you think of that? So we know that, well, just an example. So again, corresponding angles congruent? Yes. Similar? No. How about this case, though? We did this beautiful construction, and we had so much fun, this golden spiral approximation. Now, let me get rid of the spiral part for a second. And I just want to focus on, remember we really started with a rectangle and we started chopping off squares. Every time we cut off a square, the resulting rectangle, get this, like if I took this one, the resulting rectangle had exactly the same shape, meaning the ratio of the length to the width. In this case, 1.61803, golden ratio. Hey, that was really cool. Anybody remember that? If you don't, check that out, right? Plug that into your calculator, see what you come up with. Okay, we're moving on. All right, this is how you learned. You probably learned this in middle school. This is how you learn to use proportions. Maybe you said, and again, in this case, we're given A, B, C, D is similar to E, F, G, H. And it's no surprises. I mean, they're being oriented the same way. The 6 corresponds to the 9. That's the only way that we can find the rest of the measurements. Why? Because we've got the corresponding sides there. We know the measures of both. So I could say the scale factor of the small figure to the large figure is 6 to 9. I could say that simplifies 2 to 3. I could word it the other way. The scale factor large to small is 3 to 2. Maybe you do it something different. Maybe you just look at it and say, gosh, this 6 is just 2/3 of 9. Or the other way around, 9 is 1.5, 3 halves, 1.5 times 6. As long as you understand it, that's the important part. So again, maybe you wrote proportion by doing proportional sides. Remember you did this? You said, whoa, 6 is to 9 as this unknown is to 15. And you either cross multiplied or something else. But no matter what you did, or you said this, you said, well, I ain't going to just say it's 2/3 of 15. No matter what you did, you can see you get 10. Whether you cross multiply or whether you used this ratio. How about a different one? Or you did it this way. Let's suppose you want to find this blue measure. You'd say 6 is to 9 as 8 is to GH. You could cross multiply. Or you could say, I'm going to use the factor 3 halves, meaning it's just 1.5 times bigger than 8. Either way, you're going to get 12. That's how you learned it. And you probably learned that part in middle school. That's okay, stick with that. But now, you need to bust out that protractor of yours because we're going to do some drawing. And that's going to lead us into our next concept. Oh yeah. Now, if you're following my, if you don't have this already made for you, well, I guess you should could have gone to my website. I made this worksheet for you. I handed it out to my class. And I have this made out so that everything's going to fit. Now, I guess you don't even have the instructions there, but I'm going to make a 73-degree angle and add A. So how do I do that? Well, I'm going to pull out my protractor, and maybe my protractor looks like this. And I'll put the vertex on the A. See, this is a skills review. And I'm going to line it up like that. And I know that I'm reading the outside scale. See, I'm going this way, 30, 60, 70, unos, dos, tres, and there's my 73. And I'll put a mark there and then draw with my Sammy straight edge. And what do I get? I got 73 degrees. Beauteous. Now, if I slide my instrument over here, I'm now going to be reading, and well, I guess I got to tell you this. I want a 39-degree angle. 30, it's on the sheet. 10, I'm reading the inside scale. 20, 30, 40. Back it off 1 degree, and that would be your 39. Practice, keep in practice using your instruments. And there's my 39-degree angle. Beautiful. Now, the result is that, well, my other point can only be there. Huh, that's pretty cool. Now, I asked you to make other angles in a similar way. Maybe your protractor looks like this. And I asked you to make a 73-degree angle here at the W. Now I'm going to rotate my protractor like this. Notice on this protractor, the vertex is right on the edge. A cheap paper one that we handed out before. Looks like this. And I think this one's already set. And this time you can see I'm on the outer scale. Oh no, sorry, I'm on the inner scale. And I'm going to read here 73 degrees. Now you could just look at it and say, well, which way should it be? Well, heck, it should be an acute angle. If you're reading 73 and you're generating an obtuse angle, you're on the wrong side. You're reading the wrong side of your protractor. So let me move it over here. I'm going to put the vertex on the T. Oops. I'm going to line up the vertex on the T, and I am going to be reading it the other way. And now I'm reading the scale 10, 20, 30, 40. Back it off 1 degree, that's my 39. And it's going to be right there, 39 degrees. Hey, not bad for a simulated instrument, huh? And my intersection will be there. Now, when we did this in class, then we measured, well, we did a third one, and I'll just talk you through that one, but we've got a little Z over here, and I asked you to make a 73-degree angle there and a 39-degree angle at H. And the intersection was going to give me N. In the end, you said, hey, the fact that triangles, well, triangle sum theorem in Euclidean geometry tells me this has got to be 68 degrees. That's how many are left. That's 68. And this angle must also be 68, the angle ZNH. Now, that gives us a property that's unique to triangles. And this property is called Angle Angle Similarity. So the triangle ABC, follow the angles, the 73, the 39, the 68. ABC is similar to W, T, Q. And it's also similar to Z, H, N. Now, as far as scale, I did make these so that you could read them pretty easily. But maybe I should let you guys do this. I've got my simulated ruler right here. How does this work? I simulated everything in this on this screen. I could line it up there, and I could see I've got 8, because I did, or I could line it up on the 1. I read 9, subtract 1. Either way, I've got 8 centimeters. I think you're going to find 12 when you do this one, the corresponding side. And then for the Z, H, if I line this instrument up, I'm pretty sure I am going to see 4. So if you're following the paper, you maybe have come up with 8, 12, 4. Can you simplify that? Well, of course you can. That's 1, 3, 2. Or sorry, 2, 3, 1. 2, 3, 1. Sorry about that. And that was your introduction activity for this, for the concept of angle angle. Now, some textbooks will call this first angle angle angle, because if you have 3 pairs of congruent angles in triangles, they are similar. But as we can see, and as we've demonstrated with our protractors, if we have 2 pairs of congruent angles in a pair of triangles, then we have 3. and therefore the minimum necessary here is 2. Now, we're not going to prove it because what does that word say? Postulate. So I'm just going to tell you, we're going with this. That is the demonstration of the angle-angle similarity postulate. Hey, keep this in your notes, and I know it's going to be helpful. And thank you for watching 90.